The volume of a pyramid or cone is how much space the 3D solid takes up. In order to figure out the volume, we're going to need to know the height of the pyramid or the height of the cone. We learned yesterday that the height was part of a triangle inside the solid that was made up of the height, the slant height, and the apothem. In a cone, that slice triangle is made up of the height, the slant height, and the radius. So in order to figure out the volume of a pyramid or a cone, we're going to have to work with a slice triangle. The height of the pyramid or cone, the slant height, and the apothem. So to figure out the volume, we're going to use the formula for the volume of a prism or a cylinder, which is the base area times the height of the pyramid or the cone. If you remember, when we take this two-dimensional base area, that two-dimensional solid, and we extend it into the third dimension, we create a solid, which gives us volume. Now the volume of a pyramid and a cone is going to be smaller than the volume of a prism and a cylinder. How much smaller? Well, it turns out that it is exactly 1/3 smaller. Let's apply that volume formula. In example 1, we have a triangular prism. Step 1 is always to draw out the base and figure out the perimeter and the base area. In this example, the base is an equilateral triangle where each side is 12. So to figure out the perimeter, it's just 12 and 12 and 12, which is 36. To figure out the base area, I could use the formula for a triangle, 1/2 times base times my height. But since I'm working with a pyramid, I'm going to have to figure out the apothem anyways. I might as well use the formula for a regular polygon and figure out this apothem right now. To figure out the apothem, I have to remember that in a equilateral triangle, this angle is 60 degrees. So when I draw in the triangle made up of the apothem and this side and this hypotenuse, the angle that's right here is going to be half of 60 degrees, 30 degrees. And this angle right here, since we have a 30, 90, this has to be 60 degrees also. This length is going to be half of 12, 6. So I have a 30, 60, 90 triangle where I know the middle side is 6. So to go from the middle side to the shortest side, I'm going to have to get smaller. The question is, how much smaller? Well, if I knew the hypotenuse, to go to the smallest side, I'd divide by 2. If I know the middle side, to go to the smallest side, I need to divide by the square root of 3. And now I need to rationalize that denominator. So the apothem in this triangle is 2 square roots of 3. So to figure out that base area, I'm going to use the formula for the area of a regular polygon, 1/2 times the perimeter times the apothem. So I have 1/2 times 36 times 2 square roots of 3. I can simplify that. This 2 and this 2 will cancel, and I'm left with 36 square roots of 3. After figuring out the perimeter and the base area, I want to look at the slice triangle. The slice triangle is going to be a right triangle, and it's going to be made up of 3 parts. One part of it is going to be the height of my pyramid. One leg of it is going to be the apothem, and then the hypotenuse of that triangle is going to be the slant height. So I have this right triangle inside my pyramid drawn right here, where I have my apothem, which I figured out was 2 square roots of 3, and I'm told in the directions that my slant height is 4. So the piece that I don't know is my height. To figure out that height, I'm going to use the Pythagorean theorem. H squared plus 2 square roots of 3 squared equals my hypotenuse squared. Notice that I put 2 square roots of 3 in parentheses before I squared it. The reason I do that is I want to make sure that this squared extends all the way to the 2 and to the square root of 3. I can distribute powers over multiplication. So this is really 2 squared, which is 4, times the square root of 3 squared, which is 3. If you use your calculator and you forget the parentheses, you're going to end up with an answer of 6, when in reality, I should get 12. If you're getting 6, don't use your calculator. Figure this out by hand. Subtract 12. H squared is going to equal 4, which means that H is 2. So the height of my pyramid is 2. I've done all the tough work. I figured out the perimeter and the base area. I figured out all 3 sides of my slice triangle, which gives me my height, my slant height, and my apothem. Now I just need to plug numbers into the correct formulas to find my lateral area, surface area, and volume. Lateral area is 1/2 times the perimeter of my base times the slant height. So it's 1/2 times 36 times 4. I can do this math in my head. 2 in the denominator, 4 in the numerator becomes 2 in the numerator and 1 in the denominator. So I really have 36 times 2 over 1. So my lateral area is just 72 units squared. My surface area is going to be my lateral area and a bottom and 1 base area. So I have 72 and 36 square roots of 3. Well, 72 is an integer, and 36 square roots of 3 is an irrational number. These are unlike terms. I can't simplify them. So that is my final answer. 72 and 36 square roots of 3 units squared. And my volume is going to be 1/3 times my base area times my height. And I need to make sure that I use the height of the pyramid from my slice triangle. So I have 1/3 times 36 square roots of 3 times 2. If I put everything over 1, I can actually do this math in my head. 3 in the denominator, 36 in the numerator, simplifies down to 12 over 1. And now I have 12 square roots of 3 times 2, which is 24 square roots of 3 over 1. And my volume is always going to be in units cubed.